Imagine waking up one day and realizing your thoughts are no longer private. Not because you said anything, not because you typed anything, but because a machine heard your brain. This is not science fiction. This is happening right now. Brain-computer interfaces are advancing faster than almost anyone expected. They are restoring movement in paralyzed patients and allowing humans to control computers using nothing but thought. But here is the question almost no one is asking. Are brain-computer interfaces a medical miracle or the beginning of the end of mental privacy? Today, we are going beyond the hype to understand how this technology actually works and why it may redefine what it means to be human. The idea of connecting the brain to machines did not begin with technology companies. It began with loss. In the 1960s and 70s, doctors faced a brutal reality. Patients who were fully conscious but trapped inside their own bodies. Stroke survivors who could not speak. Paralyzed individuals who could not move. People who were alive but disconnected from the world around them. The question was not how to enhance humans. The question was how to give people their lives back. Researchers made a discovery that changed everything. Even when the body cannot move, the brain is still sending signals. The intention to move exists even when movement does not. If those signals could be read, damaged nerves could be bypassed entirely. That idea became the foundation of brain-computer interfaces. At its core, a brain-computer interface does three things. It reads neural signals, it decodes intention, and it translates thought into action. The human brain contains around 86 billion neurons. Every thought, every decision, every intention is electrical. When you think about moving your hand, neurons fire even if the hand never moves. Brain-computer interfaces capture these signals using electrodes. Some sit on the scalp. Some are placed inside blood vessels. Others are implanted directly into brain tissue. Artificial intelligence models learn the patterns. This pattern means move. That pattern means click. Another pattern means type. The computer is not reading your thoughts as language. It is reading intent. That distinction matters. For now, so what can brain-computer interfaces actually do today? Despite the hype, they are not mind-reading machines, but they are already capable of remarkable things. Paralyzed patients can type messages using only thought. Some can control robotic arms. Others can move digital cursors and communicate without speaking or moving at all. This is no longer experimental science. This is clinical reality. But there is a limitation rarely discussed. Brain-computer interfaces are fragile. Neural signals change from day to day. Electrodes degrade over time, and the brain itself adapts. This means systems require constant recalibration. Performance fluctuates, and long-term stability remains unsolved, and there is a deeper issue. The closer technology gets to the brain, the more personal the data becomes, which leads to the most dangerous question in neurotechnology. Who owns neural data? Think about what is already tracked today. Your location, your behavior, your attention. Now imagine technology that can infer what you intend before you act. Neural data is not like other forms of data. You can reset a password. You can cancel a credit card, but you cannot change your brain. If brain-computer interfaces become widespread, neural data could be monetized, subpoenaed, hacked, or weaponized. Once thought becomes data, mental privacy becomes fragile. And when privacy becomes fragile, control becomes possible. Brain-computer interfaces begin as medical tools, but they will not end there. Once you can restore function, you can enhance it. Faster reactions. Direct brain-to-computer communication, assisted memory. At that point, this technology stops being therapy and starts becoming augmentation. And society has not answered the most important question. Who gets enhanced first? Brain-computer interfaces could heal millions of people and unlock new forms of human potential. But they also raise questions we are not ready to answer. In the next video, we will explore the neural data privacy crisis and why current laws are completely unprepared for a world where thoughts can be measured. If you want to understand the future of the human mind, this series has only just begun.